Right guys, today we're going to go through the November 2017 paper. We're looking at paper 4, so this is one of your calculator papers. If we start with question 1, you've got Donald swims 3 lengths of a swimming pool in 93 seconds. We want to show that he could swim 100 lengths in under 55 minutes. So that means if we've got 3 lengths in 93 seconds, that means that 1 length would take 31 seconds, in which case 100 lengths would take 3,100 seconds. We want to turn that into minutes, so if I do 3,100 divided by 60, since there's 60 seconds in a minute, we're going to get 51.6 minutes, which is obviously less than the 55 minutes they asked us to show. Okay, part B, what assumption did we make? Well, we've assumed that every single length has been swam at exactly the same rate. So, swims every length at the same rate. Next one, we've got Donald tries to swim the 100 lengths in under 55 minutes. Suggest one reason why he might not achieve this. Think about it. In reality, if you're swimming 55 lengths, the likelihood is, if you're swimming 100 lengths, the likelihood is you're going to need a break at some point or you're going to get tired. So he might get tired. Would be a perfectly valid reason as to why, in reality, he might not manage it in 55 minutes. Okay, a to the power of 6 divided by a squared. When we're dividing, you just subtract the powers. So I get a to the power of 4. Powers inside and outside a bracket, you're just going to multiply, so I get b to the power of 15. Factorising, so that means we're putting it back into brackets. So if I look at this, I can't take a number out of both, but I can take an x. X times by 6 gives us 6x. X times by minus x gives us the minus x squared. Alright, question 3. You are going to need compasses for this one. We want something that is the same distance from A and B. What that means is we want to bisect the line A to B. So we want to cut it in half. So all we're going to do is you're going to imagine that there's a line between A and B. And we're going to set our compasses over halfway between A and B. Okay. All you want to do is an arc showing all the points that are that distance between A and B. We're then going to do exactly the same, not changing your compasses, but from point A. Same again. And you end up with 2 points where these curves are crossing over. With a ruler, you're just going to draw a line through those 2 points. Remember to keep this as neat as possible. Okay, and you are not going to rub out your lines. Those construction marks are basically your method marks. So anywhere along that line is the same distance from A as it is from B. Second point is we want 15 metres from C, okay? Just be very careful. It does tell you the scale is 1 centimetre represents 5 metres. So if we're doing 15 metres, what that means is we want something that is 3 centimetres from point C. So all you're going to do is set your compasses. So that, and let's make sure this is on the screen. They are exactly 3 centimetres wide. Okay, and all we're going to do is draw a circle around point C that shows all those points that are exactly 3 centimetres away. And I would advise some decent compasses. These ones, not very good. Okay, so we want something which is same distance from A and B, so it has to be on that straight line that we created, and it needs to be 15 metres from C. Okay, construct and mark the 2 points that are there. So your 2 points, nice and clearly, are that point there and that point there. It then says the points A, B, C and D represent the 4 corners of Monty's garden. So you can imagine drawing in those 4 lines. You don't need to do this, but it might help with what we're about to answer. So A, B, C and D represent the 4 corners of his garden. and it tells us, explain why there is only one position where Monty can plant his tree, given that it has to be the same distance from A and B and 3 metres from C. Well, there's only one point that is actually in Monty's garden. This point is outside of his garden. So all you need to write is there's only one place which is inside Monty's garden. Okay, so hopefully that one nice and clear. If we look at question 4, you've got here are the results of another 4 students. Be careful of this. This is the one that, because there's no line to write an answer on, is often missed in an exam. Remember to look for exam marks rather than lines to write answers on. You get 2 marks for plotting these 4 extra people. So French result of 21, this person got a German result of 30. So always check your scales first of all. For 21, you're going half a square across. Every little square represents 2. And then for 30, going upwards, each little square again is going to represent 2. So we've got 21 and 30. We've got 75 and 78. You've got 48 and 46, so 48, 14. Remember, it's every one square is 2, so 2, 4, 6. They only give you half a square to be out, so try and be as exact as possible. 53 and 61, you're going to go 1.5 squares across, and then up to 61 is just half a square up. Okay, describe the type and strength of correlation shown in this diagram. So all your points are going upwards, which means it's a positive correlation. They're all roughly following exactly the same path, so it's a strong positive correlation. And that's it. If we look at part C says work out the percentage of students whose German result was higher than their French result. Fastest way to do this is actually to draw in the line that is essentially y equals x. So I'll go through 0, 0, 10, 10, 20, 20, 30, 30 and so on. All the way through, and what we are looking for is if we want where the percentage whose German result was higher than their French. So if their German's higher than their French, they should be above the line. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 results. So that's 15. I don't need to add all of them up. It said there were 17 students so far, and we've added on another 4, so it's out of 21. So for the next part, if I've got 15 students above the line out of 21 students altogether, 15 out of 21 is going to give us 71.4% of the students. Okay, question 5. Complete this table. Now you can use table mode if you like, or you can just substitute your numbers in. I am going to run through table mode just to remind you how to do this. So on your setup, you're going to put your calculator into table mode, and I realise you guys have got a different table. On these slightly newer calculators, it's number 9. On your calculators, if you've got the original Casio ones, you're just clicking mode and 3 for table. Okay, f of x equals is just a fancy way of saying y equals, and we're going to type in our equation. So you need just above your bracket, I'm not sure if we can see this very clearly, above your bracket you've got an x. Okay, notice that that letter's in red. So what I need to do is click the alpha button and that one to get me the letter x. I want x squared plus, again, alpha and the bracket, and then minus 4. So I've got the equation that they had there. Ignore this one. If you're on the newer calculators, it then says g of x. You won't get that on the slightly older calculators. And then what you'll get is something like this. On the older calculators, it will just say start, then end, then step in 3 separate moves. This one, it's all on one. Start is your first x value, which is minus 4. Okay, click equals, it'll move on to the next one. End, you want to finish at 3. Click equals again. And step should be set to 1 because the x values are going up by 1. Which means when x was minus 4, y equaled 8. The next one was 2, which we've already got. The next one is minus 2. Next one's minus 4, minus 4, minus 2 again, 2 and 8. Okay, what I will do is just take a minute for those who haven't got table mode, okay, and just show you how to type this into your calculator. Now, if you haven't got table mode, the best thing to do is wherever there's an X, we're going to put a set of brackets. So we're going to type it in as our number squared plus our number minus 4. This way, brackets will deal with any issues with putting in negative numbers. Okay, so in the first bracket, we're going to put minus 4 all the way through. I'm only going to show this with one number just to show that it works. But we've got open bracket to begin with, minus 4 squared, plus in brackets again, minus 4, and then you had minus 4 at the end of your equation. We got 8, which is what we got from table mode. Okay, for the next one, you just type in minus 2 in there and minus 2 in there. For this one, you'd put 1 in there and 1 in there, and so on. Once you've got that, you are just plotting the points. Now remember, most importantly, an x squared graph is either a smiley face, or if it's a negative x squared, it's going to be a sad face graph, which means you should be looking for that nice symmetrical curve. If you're not getting a symmetrical curve, you've likely made a mistake somewhere. So if we look at this, we've got minus 4, 8. Can't completely fit it on the screen there. Minus 4, 8. Again, just be very careful to look at your scale. It's one big square is worth 1, whereas a big square on the y-axis is worth 2. So just be very careful with your scales. Minus 3 goes to 2. Minus 2 goes to minus 2. Minus 1 goes to minus 4. 0 goes to minus 4. 1 to minus 2. 2 to 2. And 3 to 8. So you can see those points are following that idea of a symmetrical curve. One mark is for also joining the points up. Okay, you want those points to be as smooth a curve as you can. Try not to miss any of your points. Okay, so we're going to go through those points as best you can in a nice smooth curve. Now, because you don't want a straight bottom on there, you're going to go just a bit below and keep going just to keep it making that smooth curve. And then you've got through your last points. Okay, and you get that curve. Now, part C is going to ask us, use your graph to solve where x squared plus x minus 4 is equal to 0. Well, this is the graph of x squared plus x minus 4. So when it equals 0, that basically means you want to know what 0 on the y-axis. So basically you want that point there and that point there. Okay, at that point there, I've got minus 2 point, and it is exactly minus 2.5 on mine. And on this one, it is 1.6. So I've got minus 2.5 and 1.6. Even if you get your graph wrong, make sure that you read off your points accurately from your curve. Okay, you can still get marks for that. Next point, we want on the same grid, you're going to draw the graph of y equals minus 2x minus 1. You can use the table if you wish. Now, it's up to you if you do. All you'd need to do is pick some x values. So, for example, if I picked 0 and 1, all I'm going to do is chuck those values in. Minus 2 times 0 is 0. Minus 1 is minus 1. Minus 2 times 1 is minus 2. Take away another 1 is minus 3. I'm going to plot those three coordinates to get my line. Okay, but if you don't want to do that, you can use y equals mx plus c, so you know it crosses through at minus 1, has a gradient of minus 2. Either way is absolutely fine as long as you've plotted that line. So going with the points that I worked out, I've got minus 4, minus 7. So minus 4, minus 7. I had 0, minus 1, and 1, minus 3. So 0, minus 1, and 1, minus 3, and one of those points I've plotted wrong. What we got? Oh, minus 4, 7. Sorry about that, guys. It was minus 4, positive 7, not negative 7. So minus 4 up to 7. And you can see that the 3 points that you're getting there, it's only just about in the top corner of the picture there, but you've got 3 points that are making a straight line. You can see how easy it is to make a mistake. Don't worry about it. Just always check you are aiming for a straight line. So you know quite easily if you've made a mistake somewhere. There's my straight line. And then you've got part E, says use your graph to solve the equation. X squared plus x minus 4 is equal to minus 2x minus 1. Now, you've got that line plotted already, that's your curve. You've now got that line plotted, that's your straight line that we've just done. We want to know when they're equal to each other. Now, that is just the 2 points where your curve and your line cross over. So we want that value there, and we want that value there. All we're going to do is literally read off our x values at that point. So at that point there, we're 2 squares in. So I've got there, that is minus 3.8. There's one of my values. And the other one is that point there. Let's just make sure I'm on the screen there. At that point there, you've got that value, which is 0.8. So I've got minus 3.8 and 0.8. And that's it, 2 marks. Right, if we then move on to question 6. Now, ratio, we've got initially that the white to red paint is mixed in a ratio of 2 to 3, and that she's going to make a total of 15 litres. Well, 2 and 3 would give you a total of 5 litres. So if I want 15 litres, I'm timesing by 3. That means she's currently got 6 litres of white paint in her tub, 9 litres of red. We want to know how much more red paint does she need so that this ratio of white to red becomes 1 to 5. So first of all, we know that she's only adding red paint in. So I know that the white paint has to stay as it is. So I know white has to stay as a 6. So if I make this 1 into a 6, that means that this side times by 6 would give me 30. So for the white paint to have stayed the same, red has gone from 9 to 30. So 30 subtract 9 means that you would need 21 litres of red paint added to make the ratio that she's after. Right, question 7. So polygons, remember, any straight edge shape. If we just do really quickly, if you've got a polygon, we know that the exterior angles, so that is the angles outside, all the way around the shape, will always add up to 360. Okay, so if I add up all of those, it adds to 360. Now, being a regular polygon, that means all of those angles are also the same size. So if I look at BAE, I can say that the exterior angle for shape BAE to begin with, exterior angle is just 360 degrees divided by 18. That's going to give me the exterior angle on that one, which is just 20 degrees. And then if we look back to our shape, if that's the exterior angle, then the interior angle is angles on a straight line. So if I do 180 minus 20, I'm left with the inside angle of BAE. So from there to there is a total of 160 degrees. I can now do exactly the same with CAD. Well, CAD is a 10-sided shape, so exterior angle is 360 divided by 10. It gives me an exterior angle of 36. And then to get the interior, 180 minus 36 leaves me with 144 degrees. So I know the angle from there to there is 144 degrees. So if we're looking for the angle BAC, BAC means I'm just looking for this little bit here. Well, I know all the way around is 160, the inside is 140. So if we do 160 minus 144, you are left with 16 degrees, which means, because don't forget you've got that one at the top and that one there that would both be the same angle, since this is a line of symmetry, that means I need to do 16 divided by 2. It would give me 8 degrees for the angle BAC. Okay, right, question 8 is talking about meal combinations. We want to work out the fraction of all the meal combinations which have at least one vegetarian option. You've got a couple of different ways about going about this. You can, if you want, work out every single meal combination. So you could have cheese salad with each one of your mains, prawn cocktail with each one of your mains, or mozzarella sticks with each one of your mains. Which means there's 3 options here that could be paired with any 5 there. So I know 3 times 5 is going to give me 15 possible meal options. So that's how many options I've got. I now want to know how many of those have at least one vegetarian option. Well, that is, for the vegetarian ones, I could have cheese or mozzarella, so that's 2 options, paired with any of those 5. Plus, tomato paired with cocktail would create 1. So I've got another 1 lot of 1 meal there. And then I've also got the nut meal paired with prawn cocktail. Now the reason I haven't done either of these, so tomato with cheese, is because we already started with cheese and worked that one out. So altogether I've got 10, 11, 12. So the fraction of meal combinations would be that I have 12 possible vegetarian out of 15 meals altogether. If it's easier, you can write all your pairs, but it would obviously take a little while to work it out. So if you used, for example, a letter to represent each one, you could list all of your meals. So cheese with steak, cheese with fish, cheese with tomato, cheese with pork, cheese with nut, and list every possible option, if that's easier to see kind of what's going on. Okay, that would be your 15 meal options. This is just another way of working it out if you're not quite sure what I did at the top there. In which case, out of 15, the ones that have vegetarian is all the ones that had cheese as a starter, all the ones that had mozzarella as a starter, and then out of the ones that left, the one with tomato pizza and the one with nuts are the ones that are vegetarian. So you can see you've got 12 out of 15 if that's easier to see what's going on. Next one, diners also choose one of 6 dessert options. How many different 3-course meal options are there? Well, you've got 3 starters to pick from, 5 mains and 6 desserts. You've got a total of 90 combinations. Right, question 9. We are looking at the results of a survey of people talking about whether males and females can speak Spanish or not Spanish. Because you're comparing 2 different things, the best thing to do is to create a 2-way table. You've got male, female, and total. We've got speak Spanish, can't speak Spanish, and total again. And we're going to create a 2-way table because it's the easiest way to see all your information, work out any missing information, and see what you're left with, because you do need to show clearly how you make your decision. And these ones are the ones that people easily lose marks on at GCSE, okay? And it's through not showing clearly how you got your results. So we've got 62 males speak Spanish, so male Spanish is 62. 150 females do not speak Spanish. 280 people in total don't speak Spanish, and we know that we're doing a quiz on 437 people altogether, which means all you want to do is work in pairs through these numbers. I know that this one plus this one has to equal 280, so not Spanish would be 127. This one plus this one gives me the total males, so that's 189. This one plus this one has to give me 437, so that's 248. I know that this one and this one has to give me a total of 248, so that one's 95. These 2 have to add together to give me 157. Always just double check your last 2 work out as your total, so you know that all of them work. We've then got Jeff says at least 2 out of every 5 females in the town can speak Spanish. So I've got females who can speak Spanish is 95. All the females altogether is 248. So if I've got 95 females out of 248 that can speak Spanish, times that by 100, I get 38.3%. He's trying to show that at least 2/5. Well, 2/5 times 100 gives you 40%. So your answer is no, because 38.3% is less than 40%. Okay, you've only got 38% that can actually speak Spanish. Hopefully that was nice and clear. Right, histograms. So we've got estimate the fraction of the group who had a score of 45 or more. So be very careful which way they word this. 45 or more is anything from that direction onwards. Now remember, that means that this section now is only 5, and for histograms, remember height is your frequency density, not your frequency. To get your frequency, you need the area of each bar. So we're going to imagine, that was very badly drawn, but we're going to imagine cutting our bar in half, which means I've got 5 times 0.8, that's going to give me 4. I've got 20 times 0.5, that's going to give me 10. And then I've got 30 times 0.1, that's going to give me 3. So I know I've got 17 people who scored more than 45. If we work out the total amount of people, well, I know that's 17. So I know I've got 4 there, I've got 10 there, I've got 3 there. If I work these ones out, I've got 30 times 0.2 is going to give me 6. And I know I've got 10 times 0.3, that's 3. And then don't forget the other half of this, you've got 5 times 0.8, that's another 4. So altogether, you've got 6, 3, 4, 4, 10, and 3. That gives me a total of 10, 20, 24, 27, 30. Which means the fraction you've scored 45 or more are 17 out of a possible 30 students. Right, what assumption did you make in part A? Now, these sorts of assumptions are always to do with the fact that you've cut something in half. When we've cut this in half, what we've assumed is that the people in the 40 to 50 region are evenly spread out in this class, so that 4 of them fall between 45 and 50 and 4 fall between 40 and 45. In reality, all 8 could actually fall between 49 and 50, or even between 40 and 41. They could be spread out with 7 on this side and 1 on this side. We don't know that exact detail, we've just assumed they are evenly spread. So your assumption is that they are evenly spread in the class 40 to 50, since that's the class that we cut in half. Right, y is inversely proportional. Now be very careful. If it's directly proportional, it's k times your term. In ours, it's inversely, so it's y equals k over x squared. We've then got y equals 5 when x equals 4. So if I replace what I've got there, that means to get k by itself, I need to times by 4 squared, which is 16. 5 times 16 gives me 80, which means I can now put 80 back into my equation. Y equals 80 over x squared. And that's it. I've got a formula linking x and y together. Right, question 12. You've got a log is 18 metres long, correct to the nearest metre. It's to be cut into fence posts, which are 80 centimetres long, correct to the nearest 10 centimetre. Largest number of fence posts that can be possibly cut. So first thing you want to do is, if this is 18 metres long to the nearest metre, that means your upper limit would be 18.5. Your lower limit would be 17.5, and remember that's in metres. If you want to cut that into fence posts that are 80 centimetres long, that gives you an upper limit of, since it's the nearest 10, 75 centimetres. Sorry, 85 centimetres. Lower limit is 75 centimetres. So if we want the largest number of fence posts, first of all, we need the units the same. 18.5 metres, well, there's 100 centimetres in a metre, so you get 1,850 centimetres. This one, 1,750 centimetres. Now that I've got them in the same units, if I want the largest number of fence posts possible, I want to start with the original log as big as possible. And because I'm cutting it into fence posts and I want as many as possible, I want those fence posts to be as small as possible. So I want to start with as much as possible and divide that into as little sections as possible. So I want to divide it by 75. If I divide that by 75, sorry, lost my calculator, I'm going to get an answer of 24.6 something, which means the most I can make is 24 fence posts. Okay, hopefully that made sense. Be very, very careful with upper and lower limits. If you're not sure, honestly, trial and error it and find the best number that you can make. Okay, there's only this one paired with either of them or this one paired with either. to get your answer. So there's only 4 combinations to try if you're forgetting the exact. Right, solve. X squared minus 6x plus 15 is equal to 3x minus 5. Now remember, first things first, if you're going to solve anything like this, you need your equation to equal 0. Any quadratic always has to be equal to 0. So what we've got is, if I subtract 3x from both sides, I get x squared minus 9x plus 15 is equal to minus 5. I can then add 5 to both sides. X squared minus 9x plus 20 is equal to 0. Now that it's equal to 0, it's in a form that I can factorise and solve. So 2 numbers that multiply to make 20 but add together to make minus 9 would be x minus 4 and x minus 5, which means my 2x values are 4 and 5. Hopefully nice and straightforward. Right, expand and simplify is a triple bracket, so all you're going to do is we're going to expand the first 2 brackets. Remember, you can use any method you like, FOIL or grid. If we follow FOIL, I get 2x squared plus 10x minus 1x minus 5, which simplifies to 2x squared plus 9x minus 5. So I'm now doing that answer that I've just got multiplied by the remaining bracket. And the best way to do this one is to draw it out as a grid, okay, just to make sure that you don't miss any terms. So I've got 2x squared, 9x and minus 5, 3x and minus 2. So if we multiply that out, 3x times 2x squared gives us 6x cubed. 3x times 9x is 27x squared. 3x times minus 5 is minus 15x. 2x squared times minus 2 is minus 4x squared. Minus 2 times 9 is minus 18x. Minus 2 times minus 5 is positive 10. Okay, be careful to make sure you've multiplied all the way through. It's easy to forget and add on the last one. Next one, you get 6x cubed. 27x squared, take away 4x squared, leaves me with 23x squared. Minus 15x, take away another 18x is going to give us minus 33x. And then you've got plus 10 at the end. And that's it. Equation done. Right, that's a nice 4 easy marks to pick up. Practice that if you're not sure about it at this point. Right, this one, the hated 3D Pythagoras, or SOHCAHTOA in this case. Okay, it does take a little bit of imagining kind of what's going on, but if we want angle BHF, now they've been kind enough to mark this one on here. Okay, if I want B to H to F, that means I need to know another side. I've got B to F. Either I need to know H to F or H to B. I've got nothing else connected to H to B, which means I'm going to find out H to F. If I want to find out H to F, what I've got is a triangle on the bottom there. This little corner here would be a right angle because it is a cuboid. So I know that base there is a right angle. I know that's 11 centimetres, that's 6, and that's the side that I'm looking for. Which means right angle triangle, missing a side, I'm going to use Pythagoras. It is side opposite the right angle is the longest side, so we're adding. So I'm going to do square root of 11 squared, add 6 squared. That's going to give you the square root of 157. Now you can work with decimals if you like. That's absolutely fine. There's nothing wrong with doing that. It just means try to use a number of decimal places just to make sure that you're not kind of rounding your questions in any point. So that would work out as 12.52996 and so on. It is a little bit easier if you just leave it as root 157. That means if we then look at the triangle they've given us, which is B, F and H, we're trying to find that angle there. We know B to F is 8 centimetres. We've just worked out that H to F is the square root of 157 or 12.52. I'm going to leave it as the square root of 157. Okay. From there, all we're going to do is I've got an angle involved and a right angle involved. So I'm going to do SOHCAHTOA. So I've got opposite, adjacent, hypotenuse. Hypotenuse, we don't want to know and we don't know anything about it. So I've got opposite and adjacent. That makes it the TOA part of SOHCAHTOA. Because it's the angle we're looking for, remember that means we are doing tan to the minus 1. Opposites on the top. So 8 over adjacent, which is the square root of 157. Again, if you want to, you can type in the decimal instead. It's completely up to you and depends on if your calculator leaves things in exact form or not. That means if I type in 10 to the minus 1, you should get an angle of 32.6 degrees. You may, if you've used a decimal answer, depending on how short you cut your decimal, you may get an ever so slightly different rounded answer. Okay, but as long as you make your workings nice and clear, you should still gain full marks. Right, question 14. We've got surds. So, if we've got a sum on the bottom of your fraction, which in this case is, when I say a sum, you've just got a plus or a minus. What we want to do is multiply top and bottom of this fraction by that sum, but with the sign changed. Okay, now on the bottom of the fraction, that's nice and easy to do. Root 5 times root 5, think of this as FOIL, a bracket times a bracket. First, root 5 times root 5 is 5. Now, outside and inside are going to cancel each other out. That's why we do the plus and the minus. And then last would be minus 1 times 1 is minus 1. So I know the bottom of my fraction is going to have a 4 on it. Okay, on the top of my fraction, again, we're going to treat this as FOIL, 2 brackets multiplied together. 4 times root 5 is 4 root 5. Outside is 4 times 1, that's 4. Inside, now with this one, ignore the 2 for a minute. Root 5 times root 5 is 5. Times that by 2, you're going to get 10. And then 2 root 5 times 1 is 2 root 5. So tidying that up, you've got 4 root 5 plus 2 root 5 is 6 root 5. 4 add 10 is 14. And now in this case, it does want it to be simplified because you want to show that it looks like this. All 3 of those terms divide by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. 4 divided by 2 is 2. We've got exactly what they asked for in the question. Right, this one, it might also come up as complete the square. Okay, this is the one where you half the middle term, so I get x minus 3 all squared. 3 squared, or minus 3 squared, is going to give me 9. I don't want 9, I want 20, so I need to add on another 11. Okay, so half your middle term, that term squared, and then work out what more or what less you need to get to the answer they asked for. Right, turning point. Now remember, turning point is basically on your quadratic curve, we're looking for the coordinate of that point there. Okay, now that comes from your answer here. You always do the opposite of what's in the bracket, because remember, when we talk about transforming graphs, minus 3 inside the bracket is actually going to move it positive 3 in the x direction. The number outside moves it up or down. It's positive 11, so it's positive. So all you need to remember is flip the sign of what's in the x term, keep that one as it is. So minus becomes plus, that one was a plus, stays as it was. Okay, that's the coordinate of your turning point. Right, question 17. So, what we've got is show that AC equals 13.0. So, first thing I'm going to do is just redraw out the triangle ACD. The reason I'm picking this triangle is I don't quite have enough information on this triangle to be able to find that side. So, instead, if I use this triangle, I know that angle there is 46 degrees, that's 18, that's 14, and we're trying to find that side. So, if I've got 2 sides already involved, so altogether I'm going to have 3 sides and an angle, I'm looking at the cosine rule. Now remember, for the cosine rule, it doesn't matter what letters they've given in the exam. Once you've got your triangle sorted and you know what you're talking about, relabel these corners. Okay, now what we're looking for is for the cosine rule, it's a squared equals b squared plus c squared minus 2bc cos a. Now the important thing is your angle is A, so I know the angle has to be labelled as A. That makes the opposite side A. The other 2 sides are B and C. It doesn't actually matter which way around. So I get A squared equals 18 squared, add 14 squared, minus 2 times 18 times 14 times cos 46. That's just all going to get typed into your calculator. That will give you your A squared value, which means you need to square root that answer, and you should get A equals 13.0, which is what they were asking for. Okay, next we want to calculate BC, so this time we're looking at the next triangle. We've just worked out that that is 13.0. That angle there is 78. That angle there is 81. And we're trying to work out that side along the bottom. Now this time you've got two sides and two angles involved. But remember, for it to be the sine rule, you need a side and an opposite angle. A side and an opposite angle, which means first thing I need to do is work out what that angle there is. I know angles in a triangle add up to 180. So if I do 180 minus 78 minus 81, I'm left with the angle that we're using, which is an angle of 21 degrees. Okay, so I can use that angle there is 21. Once you've got that, you can go angle A, opposite side A, angle B, opposite side B, and this one we don't actually need. So we know for sine rule, you can use the sine rule either way up, it doesn't actually matter, but because we want a side, we tend to put the sides on the side. So I know it's A over sine A equals B over sine B. All we're going to do is substitute in our numbers. You get x over sine 78 is equal to 13.0 over sine 21. And all you're going to do is rearrange to get x by itself. So we're going to multiply by sine 78. You get x equals 13.0 over sine 21 times by sine 78. Typed straight into your calculator, x works out at 35.5 centimetres. Okay, and then last question on this paper. Solve this question algebraically. Don't get tricked up by the word algebraically. You've got a quadratic equation where it's asking for answers to things like 2 decimal places, so many significant figures. It means it's a question where it will not give you nice numbers, so it's not going to factorise, which means you're going to use your quadratic formula. The term in front of x squared is your a value, the term in front of x is your b value, and including the sign, as always, the term at the end is your c value. So remember your quadratic formula first of all. You've got minus b plus or minus the square root b squared minus 4ac all over 2a. Now you get marks if you can correctly substitute your numbers into there, even if you make a mistake typing it in. So it's best to write it out first. So we get minus 5 plus or minus the square root 5 squared minus 4 times 3 times minus 1 all over 2 times 3. If you type it in once with a plus, you get 0.18. Once with a minus, you get minus 1.85. So I get my answers as x equals 0.18 and minus 1.85, both to 2 decimal places, which is what they asked for. Okay guys, hopefully you found that helpful. I know it was a very quick run through the paper, but any questions, come back and find us.